The Law of Attraction. In the previous chapters we have seen that all forms of radiant energy, viz., light, heat, electricity, and magnetism, arose from the motion of the particles of substance. It now becomes important to learn just what caused this motion of the particles. Science is somewhat hazy and foggy on this subject, but in a general way decides that it is caused by the mutual relations and positions of the particles, arising from their respective attractive qualities, as a recent writer has expressed it. Well, this is better than the old way of seeking refuge and retreat in a mere volume of dense words. It is, indeed, the only logical conclusion, this one, that the operations of the Law of Attraction are manifested in the motion of the particles. The great Law of Attraction is the greatest law in Nature. It operates on all planes of life. It is always in evidence. Let us consider it. Let us begin by considering the most magnificent and constant exhibition of that law, gravitation. Gravitation is the riddle of the universe, and the one form of energy that balks science, so much a mystery that science does not even hazard a guess at its nature. No theory of the origin and nature of gravitation is to be found in the books. Let us see what gravitation is. It is more than the power that pulls things to the earth, as the average man would define it. It does more than cause water to run downhill, and turn mill wheels to drive machinery. Water power results from gravitation, but even the energy of Niagara Falls is insignificant when compared to the other manifestations of the mother of energy, gravitation. Webster defines gravitation as that attraction or force by which all bodies or particles in the universe tend toward each other. Following that definition, let us add that every particle of substance has an attraction for every other particle. In view of our belief that this attraction is a form of mental effort, let us regard the term attraction as being a form of what we call desire, or even love, in the mental world. If you will think of it in this way, you will be better able to fall in with our lines of thought. And in addition to every particle of substance having an attraction, love, or desire for every other particle, it has the means and power to draw that other particle toward itself, and to move toward that other particle at the same time. Webster gives a very clear idea of this when he defines attraction as an invisible power in a body by which it draws anything to itself, the power in nature acting mutually between bodies, or ultimate particles, tending to draw them together or to produce their cohesion or combination, and conversely resisting separation. The majority of persons, when thinking of gravitation, are satisfied with the idea that it is a power that pulls things down to the ground, and do not think of it as a force that pulls things other ways besides down, and which is possessed and exercised by the speck of dust as well as by the whole earth, by the molecule as well as by the mass. The reason of this is that this power is so slight in small bodies of substance that it is unnoticed, and that only when the mass is sufficiently large to make the pull strong does one perceive and appreciate that the force exists. The lack of information on the part of the average person regarding this subject is amazing, particularly when the importance of the knowledge is understood. The attraction that holds the molecules of substance together is gravitation. The attraction that pulls a piece of substance to the earth is gravitation. The action that keeps the suns and planets in their orbits is gravitation. Let us see the operations of the law. In astronomy you may learn that the movements of the planets around the sun and the moons around their planets, their regular and constant relative positions, are caused by the force of gravitation. If it were not for this attraction by the sun, the planets would fly out into space like a stone from a sling. The attraction of gravitation acts on the planets just as does the string of the whirling sling that keeps the stone from flying away during the whirling until the string is released. Some astronomers think that our sun revolves around some greater sun, and this again around a greater, and so on to infinity. If this be so, then the attraction of gravitation is that which holds them all in their orbits and places in spite of their motion. And in physics you may learn that this same attraction of gravitation prevents the people and objects on the surface of the earth from flying off into space, and that it holds the portions of the earth together, preventing them from flying apart. And remember this, for it is important: the attraction of the earth, great and powerful as it is nothing more than the combined attractive power of its constituent molecules or atoms or parts. The center of the earth is the center of the attraction because it is the center of the aggregation of its particles. It must not be supposed that the earth simply attracts downward, that is, toward its center. On the contrary, large masses of earth, large mountains for instance, exert a certain degree of attraction of gravitation, and experiments have shown that a plum is slightly deflected by reason of the proximity of a large mountain. And the reason that bodies lose weight as they descend from the surface of the earth is because they leave above them a certain large portion of the molecules composing the earth, which mass of molecules exert an attraction proportionate to their mass, which attraction balances the attraction of the mass of earth beneath them. Science teaches that if the earth were hollow in the center, the weight there would be zero, or nothing at all, and that a body would float in the space at the center of the earth, just as does a balloon in the air, the reason thereof being that the attraction would be equalized, equal attraction from every direction counterbalancing each other. Considering the earth's radius to be 4,000 miles, a body that weighed 100 pounds on the surface would weigh but 75 pounds at the depth of 1,000 miles, but 50 pounds at a depth of 2,000 miles, but 25 pounds at a depth of 3,000 miles, and nothing or zero at a depth of 4,000 miles, which would be the center of the earth. This, of course, supposes that the substance of which the earth is composed is of uniform density from surface to center. From an equal distance above the surface of the earth, bodies released or dropped will reach the surface at exactly the same degree of speed, and in exactly the same time, this irrespective of weight or size. In other words, a cork or piece of lead, no matter what their sizes may be, will travel with equal rapidity. In case where the lighter substance travels more slowly, compare a feather and bullet for instance, the difference is caused by the light object meeting with more resistance from the air. The apparent exception has been explained away by the experiment of dropping the bullet and the feather in a vacuum tube, in which there is no resistance from air, the consequence being that both descended precisely at the same instant. Another similar experiment is to place the feather upon a piece of iron whereby the resistance of the air is prevented, and the feather will maintain its position during the drop, and will reach the ground resting on top of the iron, just as it started. And, remember this please, that the small object attracted by the earth exerts an attraction on its own account. If the two were of the same size they would exert an equal attracting power. But as one is similar, its attracting power is very slight compared with that of the large mass. But it is true that the particle of dust attracts the earth precisely as the earth attracts the particle of dust, the difference being solely a matter of degree depending upon the mass of the body. The amount or degree of the combined attracting power is determined by the combined total of the two masses. Distance lessens the degree of attraction. Thus, as bodies are lifted above the earth, the weight decreases very gradually, and by very slight degrees, but constantly and invariably. The poles of the earth are flattened, and consequently the weight of an object slightly increases as it is carried from equator to pole. Concluding our consideration of gravitation, it will be well to call your attention to the fact that gravitation differs from the forms of radiant energy known as heat, light, electricity, and magnetism in several very important particulars, which seems to go far in the direction of proof that the latter are by incidents or consequences of the former. In the first place, gravitation, so far as is known, is not dependent upon, caused by, or maintained by any other force or form of energy. nor does it seem to be derived from some great reservoir, from which it obtains its supply of energy. On the contrary, it seems to be a "thing in itself," self-supporting, self-existing, an intrinsic thing, in fact. It does not seem to be lost to bodies by radiation, and consequently there seems to be no need of a body replenishing its supply, as there is no loss. Gravitation seems to be a constant something, remaining always with bodies and neither being lost or acquired. It exists between the atoms, molecules, masses, all in the same way. In fact, one is tempted to think of the planets and worlds in space as molecules of some greater mass held together by gravitation, just as are the molecules held together. Remember that the molecules and atoms are not in absolute contact, but there is always a space between them, although the space or distance may be insensible to us. "As above, so below," says the old occult aphorism, and it seems to be so. Then again, gravitation is believed to act instantaneously, and does not require time to pass between bodies, as does light, heat, electricity, magnetism, radiant energy. Light travels through the ether as light waves at the rate of 184,000 miles a second. The same is true of heat and of electricity. But gravitation travels instantaneously. For instance, if a new star were to spring into existence at some inconceivable distance from the earth, it would require thousands of years for its light to reach us. But its attraction of gravitation would be felt instantly. Do you realize what this means? It means that gravitation is in some way connected with the ether or conveying medium, that an impulse communicated at some point of space, trillions of miles away, is felt at once at our point in space, and vice versa. There is some awful mystery here, and the laws of substance and force, as generally understood, do not account for it. And the theories regarding the ether do not throw light upon it. But wait a bit. But more than this, science holds that gravitation does not require a medium, that it seems to be its own medium, needing no ether or other medium to transmit its influence. In this respect also, gravitation differs from the form of radiant energy, and more, it is not cut off or interfered with by any intervening body, for its force operates through such intervening bodies. For instance, in an eclipse of the sun, the moon passes between the earth and the sun, but the gravitation is not affected in the slightest, for the bodies would evidence such changes immediately were it to occur. So gravitation acts instantaneously, is its own medium, and may not be interfered with by an intervening body. It, indeed, is in a different class from light, heat, and electricity. And now let us consider the other forms of attraction. In the previous chapters we saw that the form of attraction called Cohesion caused the molecules to tend to each other, and to remain in more or less close contact, the differing degrees of cohesion determining the density, etc., of the body. Were the attractive force of cohesion suddenly removed, the most solid bodies, as well as the lightest ones, would instantly fly into very fine powder, thus being resolved into their constituent molecules. The separation of the molecules, that is, the setting further apart, occasioned by heat, is spoken of by physicists as repulsion. But the writer holds that repulsion is an entirely different thing, and that the heat merely causes the molecules to lose a portion of their attractive power for each other. Until the heat being withdrawn, the molecules respond to the uninterrupted attraction. The molecules are like lovers who are attracted toward each other and remain attached unless separated violently or by some fading of attraction. Consider heat as a disturbing element, a misunderstanding between the molecular lovers, who under its influence draw somewhat apart, and are only reunited when the obstacle is removed and harmony again manifested. As we have shown you in a previous chapter, the so-called properties of matter, i.e., hardness, tenacity, malleability, ductility, etc., are simply evidence of a persistent cohesiveness of the molecules, a strong love or desire for each other that caused them to adopt every possible means in their power to resist and prevent the separation of the molecules forming the mass. It was like a desperate attempt to prevent the breaking up of the family. Each so-called special physical property of matter is seen to be but the action of the molecule resisting separation, in obedience to that law of its being called attraction, or gravitation, or cohesion, or adhesion, but which might as fitly be called desire or love. And remember that this law does not seem to be merely one of self-preservation of the molecule, for it remains intact even after the separation from its companions or family. Each so-called special physical property of matter is seen to be but the action of the molecule resisting separation, in obedience to that law of its being called attraction, or gravitation, or cohesion, or adhesion, but which might as fitly be called desire or love. And remember that this law does not seem to be merely one of self-preservation of the molecule, for it remains intact even after the separation from its companions or family. It is more, for it is a law that causes it to bend all its energies in remaining within molecular distance, or close companionship with its family, and resisting disintegration. It is like the social instinct in man, if one may be pardoned from using the figure. Now for the attraction of the atoms, chemical affinity, or chemism, as it is called. An atom, you know, is the chemical unit of matter, and the smallest particle of matter that can enter into combination, leaving the corpuscle out of the consideration for the moment. These atoms exhibit and manifest an attraction for each other that causes them to form combinations or marriages, and thus to combine, forming a molecule. But remember always that when atoms combine they do not merge their identities, they simply marry and nothing more. Each atom maintains its own identity, and is found intact if the marriage is destroyed by chemical process, which might be called the termination of the molecular marriage by divorce, that is, by one atom forsaking its mate and seeking a new affinity in the shape of some more attractive or attracting atom. For alas, the atoms are more or less fickle, and often leave their life partners for some other fascinating particle. At times there is manifested a condition of "How happy could I be with either, were to other fair charmer away." There is a conflict of attractions. There is more flirting and affairs of the heart in the world of atoms than in the region of the molecules, for while the latter are apt to seek only the companionship of their own family, or some nearly related family, the atoms have quite a number of possible affinities, and will invariably desert a lesser attraction for a greater one, thus forming a new molecule, and leave the deserted one to get along alone as best it may, or else form a new alliance with some other affinity who is either impervious to the attraction of the more brilliant charmer, or else is out of the danger of temptation. But if we analyze and carefully consider this chemical affinity, chemism, we will see that it comes well under the definition of attraction, as given by Webster, and quoted in the first part of this chapter. It certainly comes under the rule of the power in nature acting mutually between bodies or ultimate particles, tending to draw them together, etc. The writer thinks that he is justified in asking you to consider gravitation, cohesion, adhesion, and chemical affinity as related forms of the same thing. If you do not like to call this same thing by the name of gravitation, suppose we call it the law of attraction, of which gravitation, cohesion, adhesion, chemical affinity, or chemism are but different aspects. This relation is described in Chapter 13. And the writer believes that this law of attraction is the underlying cause of all that we call energy, force, power, motion, etc., in the physical world. For if gravitation accounts for all mass motion, or mechanical motion, if molecular cohesion, and the vibrations accompanying it, manifest in forms of molecular motion, and if atomic chemical affinity, or chemism, manifests in atomic motion, and if even the corpuscles in their movements obey this same law of attraction in some form, and if all force and energy is but a mode of motion, then, if all this be true, are we not justified in claiming that this law of attraction is the basis of all energy, force, and motion? And are we not justified in thinking of this law of attraction as always manifesting in the direction of drawing together particles of Substance, be those particles suns, planets, masses, molecules, atoms, or corpuscles, in pursuance of some basic law imposed upon all things by that which is above things? The following quotation is interesting in our consideration of this subject. There are other forces besides gravity, and one of the most active of these is chemical affinity. Thus, for instance, an atom of oxygen has a very strong attraction for one of carbon, and we may compare these two atoms to the earth and a stone lodged upon the top of a house. Within certain limits this attraction is intensely powerful, so that when an atom of carbon and one of oxygen have been separated from each other, we have a species of energy of position just as truly as when a stone has been separated from the earth. Thus, by having a large quantity of oxygen and a large quantity of carbon in separate states, we are in possession of a large store of energy of position. When we allowed the stone and the earth to rush together, the energy of position was transformed into that of actual motion, and we should therefore expect something similar to happen when the separated carbon and oxygen are allowed to rush together. This takes place when we burn coal in our fires, and the primary result, as far as energy is concerned, is the production of a large amount of heat. We are, therefore, led to conjecture that heat may denote a motion of particles on the small scale, just as the rushing together of the stone and the earth denotes a motion on the large. It thus appears that we may have invisible molecular energy as well as visible mechanical energy. Balfour Stewart. To the writer it seems that the particle of Substance finds within its mind principle, for you know we have seen that all Substance had something akin to life and mind, a constant craving, embedded in its very nature, which causes it to seek satisfaction. This craving for satisfaction results in unrest, and seeks a solution along two lines. These two lines are indicated by two entirely different desires that it finds within itself, the first being a desire or inclination to seek the companionship of some other particle, the second being a desire or inclination to be free of attachment or entanglement. The desire for attachment arises from the force of the law of attraction that exists between each particle of Substance. The desire for non-attachment arises from some inward inclination for freedom. These two desires or inclinations may be called the desire for impression and the desire for expression. The desire for impression, or pressing in, manifests along lines of action tending toward attachment, moreness, companionship, combination. The desire for expression, or pressing out, manifests along the lines of action tending toward individuality, freedom, independence, unattachment, etc. And both are strong cravings, and both tend to produce unrest, which results in motion. The pull of the desire of impression exists always, and is always modified and counteracted by the push of the desire for expression. And resulting from the play of these two desires or forces result activity, motion, and change. Like the two conflicting angels in the Persian mythology, Ahriman and Ormuzd, these two desires wrestle with each other in the theater of the universe, constant motion and change being the results. And, if the writer may be pardoned for dropping into mysticism for the moment, may it not be that these conflicting desires for separateness and unity, respectively, are but different forms of the desire for satisfaction through oneness? Impression seeks oneness by combination with other separated particles, but finds it not. Expression seeks oneness by drawing apart and endeavoring to realize it in that way, but finds it not. But both are but different aspects of the same desire for satisfaction, and only when the mind recognizes oneness in diversity does satisfaction come, and thus the lesson of the particle becomes the lesson of the man. These conflicting desires of inclinations of the particles, the one urging it along the lines of attraction, the other along the lines of separation, produce the dance of the atoms. The motion of the particles. When the particle manifests along the lines of expression, it pushes itself away from the other particle, and, consequently, also pushes the other particle away. When it manifests along the lines of impression, it pulls itself toward the other particle, and at the same time pulls the other particle toward itself. In both cases, the medium of the pulling extends over the space separating them, as will be described in future chapters. This pulling and pushing is called by chemistry attraction and repulsion of the particles. It is perhaps unnecessary to state that the force of the attraction of cohesion, or of chemical affinity, is much stronger than that of gravitation in the case of the same particles. Otherwise, if one picked up a piece of iron, the attraction of gravitation would cause its particles to separate and fall to the ground, whereas the attraction of cohesion and that of chemical affinity enable the particles to counteract the pull of gravitation and thus remain intact. Compared with cohesion or chemical affinity, the pull of gravitation is incomparably weak. The force which holds together two atoms of water represents a high degree of dynamic power, and the shock of forcible separation of chemical atoms produces something akin to an explosion. So we see that the attraction of the particles, while of the same nature as gravitation, is much higher in intensity. But notwithstanding the power of the attraction, it seems to be a matter inherent in the nature of the particle, and to represent a something like Will in response to Desire. The varying push and pull, or the two desires, would necessarily cause a revolution of each particle on its own axis, and a revolution around each other, besides many instances of rushing together and away from each other. In these forms of motion is to be found the cause of the vibrations producing radiant energy known as light, heat, electricity, and magnetism.